you doing? Just thought I'd make another video. I'm going to show you my new motor. Okay, this is my V-twin. You can see the magnets inside of it. Let's get over here where you can see it. And that's the position they fire in. I have both of the coils hooked together when that switch makes contact. And the little piece of brass is on the bottom. Copper rather, not brass. So when that switch makes contact, both of these coils fire together and they fire opposite polarities. And those magnets are oriented north and south. So it'll pick up one coil will pick up a magnet while the other coil pushes the other one down. It only fires one time per revolution, and that's the motor. The contacts on the top here are the positive and negative that go to the battery. Now what I want to show you is how you translate voltage into current. First I want to demonstrate that this has absolutely no current in it. Okay, this is the wire here I have in my hand. Goes straight to the negative, or positive, sorry. And you'll see when I touch it, you can hear it hit. There's no, very little, I don't know if I can see a spark or not. No, it's just a light. Okay. Yeah, there's no spark. And to further show that, I got the meter hooked up. If I can do this. Now, I got the positive of the meter hooked up so we can see. I'll try to put this where we can see both. So what I'm going to do is first show you the voltage of the battery. And voltage will always stay in a battery just as long as the battery's in good shape. It's like a playground to the voltage, the radiant energy that's around us. It likes to be in it. When they build a battery, they don't have to put voltage in it. The voltage just automatically goes there. It's a way of, it's what we call the surface charge of a battery, which is the radiant energy that's all around us. Now, when I short it out, you see there was no spark. There's no current. Okay, I'm going to try to hold this on here. This is going to be difficult. Now, let me try to do this with one hand. Both of these together. I know what. I'll just hook this on here. Now, you've seen the voltage when I touched it before. Now I'll touch it. And you see the voltage now. It goes down to almost nothing. I take this wire clip off here so it's not a dead short, and you'll see the voltage comes back. And it'll continue to keep coming back. Now that voltage will not run this motor with just the voltage itself. Now I'll hook up, see, we'll hook up the positive to, doesn't matter which one. Now we'll hook up, grab another wire. We'll hook this up here. And then the other end of that wire we'll hook up to the negative. Okay. So now, you'll see when we turn this, I'll turn from the other end. Okay. Let's see which way it wants to turn. Okay. Now the voltage, when I turn it, you'll see when it makes contact, it'll carry it through the contact. That's it. That's all that it'll do. That's it. Now that's 8 or 9 volts. That's the only push it gives it. Okay. So now let's hook up the capacitor so that the voltage will charge the capacitor. The capacitor will translate it into instantaneous current, and that's all you need to run a motor. Now this wire here is the positive, so we'll hook it to the positive because you hook it in parallel. And then there's another wire here, so here it is. Then we'll hook this wire to the negative. And this is a spliced wire, so it's red and green. Christmas colors, cool. Okay, then this one goes on the negative. Now, let's see, it doesn't do anything to the voltage. The battery stays the same. you know. Of course, now it went down a little bit because now it's charging the capacitor. And now it's coming back up. Okay, so now the motor's all ready. So now when I give it a little bit of a turn, and it starts to make contact. And you can see it sparking. The only thing I did was hook that capacitor in parallel with the battery. Now I've seen videos where they say there's been guys making motors that power their cars and they only run off of 1 or 2 12-volt batteries, and when the batteries, you know, you use them until they're done, they're junk, and then you throw them away, buy 2 new. Now I don't know how long it takes to actually destroy a battery, but I'm pretty sure that they probably started out with dead batteries to start with, batteries that were junk anyway. Because that's what you want. You don't want a battery with current, because then you got to figure out how to separate the current from the voltage. And this is my thought that occurred to me when you I've heard before that voltage is much faster than current. You know, if you put voltage and current side by side, it's like the race between the turtle and the hare. Voltage is lightning fast, but the thing is, I've learned from Keshi, Moran Kesh, is everything has a magnetic field around it. So I believe that the magnetic field around voltage is a weak magnetic field, and as long as it isn't around a strong magnetic field like current, it'll go the speed it wants to go. But when you put voltage and current together, now the current holds the voltage to the same speed. So, and I believe that's what's happening. But when you can eliminate the current by either using a dead battery or whatever means that you can think of using, when you eliminate current, now the voltage can go the speed it wants to go. So you can see that the speed of the voltage coming out of the battery into the capacitor and being translated is fast enough to run the motor. Now that's a lot of triggering. I mean, it's only firing once every revolution, but I've made motors that fired twice every revolution, and you get plenty of power. And the voltage doesn't read right when you hook up the voltmeter. It's all over the place. So it's really, with the meters that we have, you can't really, you know, get any accurate reading like we're used to seeing when it's running. But you can see that it runs. And I could let this run until this contact burns up. It won't run out of voltage. The surface charge in the battery will continually feed the capacitor and continually run that motor as long as the contacts stay good. But, you know, this is the second time I've replaced the contact. So I just wanted to make this video to show, you know, I find myself in a position where I'm always trying to prove that free energy is real. And, you know, it's getting redundant. You know, I mean, it's apparent that it's real, and there's other avenues we can do. We don't have to burn fossil fuel. And I don't want to get into the Debbie Downer, you know. But, you know, the fact is we don't. We can continually have energy. And I believe this guy right here is the heart of free energy, the capacitor. And I heard a man by the name, he was a scientist, and I can't remember his name right now, but he said that the ionosphere, where lightning originates, is like a capacitor. And that's why we have lightning. I don't understand the technical, you know, but I'm pretty sure that's not, maybe not word for word, but in my interpretation, that's what he said. So what we're doing here is we're taking the voltage and making our homemade, or not homemade, but our ionosphere in a bottle. I don't know, whatever you want to call it. And it's actually translating the voltage around us into lightning fast current, instantaneous current. And that's all we need to run a motor. So I'm not going to keep dwelling on this. I'm not going to make any more videos on this. This is pretty, you know, like I said, it's getting redundant. But the fact is, this motor that I made, it's working pretty good. You know, it's a V-twin, and you know, if I had stronger magnets, it would even be stronger. If I had more wire around the coils, and I'm using pretty heavy wire. These wires from a transformer, and it's pretty heavy gauge. I don't know what gauge it is, but it's pretty thick. And I found through experiments that the thicker wire is better, and that's exactly what Joseph Newman said. And I believe it's because the diameter of the wire, the radiant energy is around the outside of the wire. And I've heard John Bedini say that. So the smaller wire, the smaller surface you have for radiant energy. The bigger wire, the bigger surface. And I think that's the only reason why bigger wire works better. So, you know, and I've showed in other videos with the Bedini, the more wire you add, the more energy output you get, and the less energy input you need. So this is going to constantly feed the same rate, but the less that we need here, by adding more wire, bigger magnets, get more power, you use less energy, then you can see that the bigger the motor, the less energy you take and the more power you get. So I just wanted to make this video. The contacts are starting to get worn. It doesn't take long. You know, when it starts slowing down and speeding up a little bit, then you know the contacts are getting ate away. If I leave it on there too long, or if I push too hard on the contacts, it'll actually heat up these wires so much that contact that I have glued onto the electrical tape, the glue will actually come loose, and contact will just go flying. But if I make something where the contact can't go flying and that it's not held on by glue and heat doesn't affect it, it would just continually run until the contact itself burn out. Well, I just want to make this video, and I believe it's probably my last one. I love you guys, but you know, it's getting kind of redundant. Actually called Tesla Motors and scheduled a test drive. And talking to the gentleman, he asked me if I had any questions, and I told him that, well, I just found it fascinating that a supercharger that runs off of solar panels can charge a Tesla car faster than I could charge my cell phone. And I believe that he's, you know, I did a little bit of research, found out that Elon Musk, before he made his millions, where he did a lot of studying, and I think he built capacitors. So he understands this. And I believe the supercharger has something, you know, this kind of technology built into it. I don't know how else it could charge a car that fast off of the sun. You know, the guy didn't, you know, he told me that not all superchargers run totally off solar panels because there's not enough sun in certain areas, which makes perfect sense. And oddly enough, after he told me that, another day or two later, I heard where Elon Musk said that all superchargers here in the near future will be ran totally off of the grid. So whatever means he's talking about using. You know, but I know it's very possible. I'm looking at it. So, but anyway, when I take my test ride in the Tesla, my wife's going with me. We're going to have the camera, and I'll post that video. And well, video's long enough, I guess. I just wanted to post this and drive this into the ground one more time, and then I'm going to let it go. I'm going to go ahead and I'm going to try to build a motor that'll run my lawnmower so I can get away from the vaporizing fuel or using hydrogen, you know, explosive. Because this is clean as you can get. And this is abundant energy that's all around us all the time. So, this is the path I want to go to try to make my lawnmower. So I just wanted to make this video, and thank you guys for everybody that's subscribed and checked out my fish video. Pretty popular video. Thanks for all the comments, good and bad. And well, God bless.